We can calculate the mean and standard deviation directly from their definitions this way. So the mean, x bar of a set of n samples, is just 1 over n times the sum of all of the different values that x takes on in that n samples. So that's going from I equals 1 to n. And likewise, the variance is defined, and that's just the square of the standard deviation, so sigma squared, as the average of the square of the deviation of any sample from the mean. So that's again going from I equals 1 to n, xi minus x bar, so that's the difference of any one sample from the mean of all the samples, squared, so that's always positive. So when you add those up, in fact, we could do that square inside that summation, and we'd get 1 over n times the sum, and I'm going to drop these indices here just for ease of writing, of x squared minus 2xi x bar plus x bar squared. So we're summing all of these. Now, if I write that again, I'll get 1 over n, and we're going to have the sum sigma xi squared, that's from there. Then we'll have minus 2x bar times the sum of xi, because these are constants I can take outside the summation. But the sum of xi over n, that's just going to give us back the mean. And then over here we're going to have x squared. Well, that's the same over all n of those summations. So that's just n times x bar. So that'll be equal to 1 over n, the sum of xi squared, minus 2 times x bar, and that is just n times x bar. So minus 2n x bar squared plus n x bar squared. Combining those, 1 over n, the sum xi squared, that's going to wind up being net negative n x bar squared minus n x bar squared. But remember, x bar is equal to 1 over n, the sum of xi. So x bar squared will be equal to 1 over n squared times the sum of xi squared. So 1 over n squared times n will just give us 1 over n. So it'll be 1 over n times the sum of xi squared minus 1 over n times the sum of xi all squared. And that's something that's easy to calculate if we just keep a running total of what's the sum of the squares and what's the sum of the individual samples. So we can do that as we keep on running through and getting more and more and more samples. Now it's important to note that that n value there, that's for a population variance. So that n value there would be n minus 1, because we have a reduction in degrees of freedom for the sample variance. And that's the same n as this one down here when we eventually get there. And finally, the standard deviation is just the square root of the variance. And its symbol is sigma, and it's the square root of sigma squared, as you would expect. So you can go through this process of calculating the mean and the standard deviation directly from those samples, or you can use the various functions that are available in spreadsheets or in Python or in MATLAB if you're using one of those high-level languages. But if we want to calculate means and standard deviations inside our Arduino code, we're going to need to be able to do this kind of a calculation.